Hello and welcome to Math, Minecraft, and Computers episode I38, where we are going to build a binary adder. So last time we talked about binary addition and how it works, and you created this truth table that shows exactly all the various states. Recall that we have an A and a B bit. Those are the two bits that we want to add. And we have a carry in bit that indicates whether we have a carry operation or a carry from the last operation. And then we have an output bit and a carry out. As you can see, the table has entries for all three of those, whether we have whatever state. There are 8 different states. And so we just need to build a circuit that does this. Now, the first thing that you might notice right away is that if any of the bits are on, then we want to make sure that we have data out. And that's fairly easy. If we have 2 of the bits on, then we end up with a 0. So whether A and B is on, or A and the carry, or B and the carry is on, we end up with that. So the first thing we can do is we can accomplish that by using some XOR gates. So let me open up gates here. The first thing I'm going to do is grab an XOR gate out of here. I'm going to click on it there. I'm going to set it for 2 inputs. And we're going to use the small ones, the narrow. Okay, so there is our gates. So let's get our inputs set up. There's A. Go ahead and label that. And we'll have B. As well. And of course, then we're going to have carry in. So let me put that here as well. So we're just going to say C in. So there's our bit. So the first thing we want to do is we said, if A and B are on, if either is on but not the other, then we want to have an output. So I'm also going to grab an LED and this will be our output. Here I'm going to have that actually face south so that it points up. I'll put it there like this. Okay, so we've got this set up already. And this is going to show whether A or B is on, but not both. Now to also get that last chunk that I mentioned, we're going to copy this gate and put it here. We want to say if any of the 3 are on, since this will only be on, as you can tell, we go to sim mode, that gate only comes on. I'll drag it out so you can see it. That gate only comes on if they're both on, it goes off. If they're both off, it's off, only if one or the other is on. So we're going to do that again with the carry flag. So we just bring this down to here and into the carry. That last chunk correct. So now we have the carry as well. So let me go ahead and hook this up out to our LED output so that we can see it better. And there it is. So any bit on of the 3 will turn on the light. If any 2 are on, the light will go out. It doesn't matter which 2 are on. So that's our data if you think about it, because if we have a 0, 0, according to the table 0, the data bit is off. If we have a 0, 1, 0, it's on. If we have a 1, 0, 0, it's on. And if we have a 0, 0, 1, it is on as well. So that's set up pretty easy. Now what we have to handle is the situations when you have more than one on, because we have a 0 and we want the carry on, so we have to handle the carry logic. And in this case, we want the data bit on exactly like we have, because what we have here is this one is off because they're both on, and this one is on, and so that handles all of our data. So we're set. All we really need to handle now is the carry itself, the actual carry flag. How do we accomplish that? Well, we know we want to carry if these 2 bits are on. So that sounds like if either of those are on, we're going to need an AND gate. And so we'll do the same thing. I'm going to set this to narrow and 2. And I'm going to go ahead and think I will face it, in this case, south, like this. And I'm going to capture those 2. I think I'll go ahead and move this up and get it a little more space available here, like so. And then we're saying if this is on and this is on, then we have a carry, so we know that. And then we also want to say what happens then, how do we get this last chunk? So if any of these two are on, like that, we also want to carry. So that just says we simply need to have another one of these gates. Except we want to put it on these two lines. So I'm going to move it up here, and we're going to attach it and say that this is going to go to this one, and this is going to go to this one. So now we have a situation where this is going to be on, this gate is going to be on, if any of these two are on. So I can slip these two, flip them, and you'll see I get the same thing. So anytime that I have two bits on, I have this gate on. If these two are on, this gate turns on to indicate we have a carry. And if these two are on, we have the same thing. So we've taken care of it. It's pretty simple to do. Now we've got our data. The difference is, of course, if this situation or this is on, if either of them, that's an OR gate. So we're going to grab an OR gate here. We will set it for narrow as well, and 2 data bits and facing east is fine. We're going to go ahead and just put it in this area. I'm going to make this smaller and drag this up to there. And then this one will connect to that one. Looks like we can drag this down to about right there. All right, there's our connection to that gate. This gate can come up here then and connect to this one. So these are going to be our 2 outputs. And if we've done this right, drag an LED here. It faces east, and we put it right here. Needs to face west. And we attach it to this location. We're going to label this one as C out, and this one is going to be data, like so. I'm going to put that label on the north so we can see it, and I'll do the same thing here. I'll put this label on the south. There we go. Here you have exactly what we need. We can go through our table and go through all the states. We'll start with 0, 0, 0. We have no data, we have no carry. 0, 1, 0. We have data, but no carry. 1, 0, 0, same thing, data, no carry. Or 0, 0, 1, data, or no carry. Now we'll go to the case where we have A on and B on. In that case, we have no data, it's a 0, and we have a carry on. If we have A and C on, the carry in on, then we have the same thing. We have no data, it's a 0, and the carry is on. And of course, that leaves us also B and the carry, same thing. The last thing is what happens here. If we've got it right, when we click on A, data should come on and carry should come on, and indeed, if all 3 are on. So that is handling a single bit. If you think about A and B being a bit, and I'm going to relabel these now to be A0, and this one will then be B0, that's the first bit. And then I'm going to drag this carry in out here. That would be our carry in only into this first circuit. But now, how can we do this for multiple bits? Well, let me clean this up a little bit first. I'm going to get these closer to where I want them. I'm going to drag this down to there. I'm going to drag this over to there. I'm going to take this LED out because how we're going to do this is we want to make sure we connect this. Okay, I like my circuit now. Let me move it up and over there. Now, really all we want to do is we want to copy this, but we only want to copy certain parts of it. So what I'm going to do for now is I'm going to make one copy of this by dragging it all. Okay, so I'm going to copy that and I'm going to drag it right down here and line it up with a little bit of space. Now, our carry in, you see, comes into this lane right here. And so what I want to do to make this a little bit easier, I am going to drag this particular AND gate. I'm going to drag it over to here. I've got the connections added too, so it's probably easier to drag the gate to there and then delete the connections and re-add them. Okay, so this is bit 0, if we think about it as that. So this is only going to do the first bit between an 8-bit value. And so I'll name them B0 and A0, and then these, of course, would be the next bit over, which would be bit 1 for A and B1. Just labeled that, going to have the A on there. So this is A1 and this is B1. And we don't have this carry in because this carry in actually, if you think about when we had the second bit, that carry in comes from here. So I just need to bring this down and connect it up to here, like this. So now the carry from this, I can actually drag this over here and do the same thing here to make this even easier. So the only other thing we do is we're going to call this D0 now. So that's the first bit out of the circuit. And this is going to be D1. So now can we add 2 bits? This is the new carry right here. So in this case, if we carry out, so I'm just going to turn these on, you'll see that we actually have a 2, and this is bit 1, so there's the 2 in the data. As soon as I add another carry, you can see that we added there, so there's 3. So all we have to do 8 bits is we take this circuit 7 times and copy it. Okay, now that we have 7 copies of it, well, of course what we need to do is we need to get an output on all of these. I didn't copy that, that's easy enough to do. And then of course I need to change these labels for both the bits over here, the inputs and the bits. So let me get that done. We've got everything labeled. All we have to do now is hook up our circuits. I should have done this probably first. Okay, so there we've got the carry from each of these, which is this one right here, connected to the carry input. And then this has its own carry in coming from a previous operation. So the only other thing we need is we're going to put an output right here. And we're going to call that C out. That is now our carry out. I'm going to set that label also to be on the south, and I'm going to go ahead and drag this out a little bit further to make it easier to see. I'm going to need to have that one facing west, actually. And the label, I want it on the south, and I want this facing west, and there we go. What I would do is I would simply put with the value of A on A0 through A7, and I put the value of B on B0 through B7, and then I'll have my output for my 7 bits, 0 through 7 would be my answer, and then my final carry out is here. So let's put something on real quick. We'll just automatically add A if A is 1 and B is 0. Then, of course, what we get is all bits are on. As soon as I go in and add any additional B, what you get is a flip. So that means all of these turn off because we're carrying, and that causes a carry, 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 and it ends up down here. So it's a very simple circuit at this point. It's called a ripple adder. It's called a ripple because the data ripples from this circuit to this one. So it's not the fastest circuit because we have to have a result here before we can get a result here, because the carries are all hooked up. But it's a basic adder and it works well. We could do this as a 4-bit adder or an 8-bit adder. This is an 8-bit adder. But what it means, of course, if I wanted to add a 16-bit value, what I could do is this carry out could be stored, and then I could put the next 8 bits in A and B and move that carry out from the previous operation to the carry in, and this adder would keep going. So I can actually add as many bits as I want using this circuit. And that's all we have to do to create an adder. So put whatever value you want here on A and B. We'll go ahead and add a bunch of these. And as soon as I do a carry, I get the last additional one added here. Because that's all I can do on this carry in, right? Is turn that bit on. But you can see that the carry is coming here. If I keep adding bits here, we'll end up with a situation where I carry to here. So that is an 8-bit ripple adder that I think is a very old circuit. I'm not sure when this was designed or who originally designed it, but it's been around a long time. So what we'll do next time in I39 is we will actually build this circuit in Minecraft. So until then, this is Imroy. Keep on learning. Don't forget that subscribe button and likes. We'll see you. This is Imroy out.